Now, just to exemplify this, I'm going to do the same thing on Google. And if you just put in the same value that I just mentioned, sine zero point 0.1 by zero point 0.1, you get this. Now, if we have this value tend even closer to 0, say we take a smaller number, instead of zero point 0.1, we take 0.01, and you'll get this as the value. Now, the closer you get to 0, the closer you'll see this value go towards 1. You see how this is very, very close to 1. You add one more 0, and it's almost going to be 1, as we see. Now, this is, let me just put this in our slides and look at it once again. Now let's look at this value once again. At 0.1, we saw a value that was very close to 1, that's 0.998. At 0.01, we saw this value go even closer, with the final value of f of x being 0.99998, and so on. In this value, you see a value that's even more closer, and at 10 raised to minus 6, you get a value that is nearly 1. What this may lead you to conclude is that when x tends to go to 0, sin x by x will tend to go to 1. Mathematically, you'll represent it as the following: x tends to 0, sin x by x tends to 1. And formally, the entire statement looks like this: limit x tends to 0, sin x by x equals to 1. At this very critical juncture, you must realize that x is never actually equal to 0. It's just super, super close to 0. That is the meaning of tends to something else. You'll know this in more detail when we go forward. But just to illustrate this, let's look at the same function on the number line. So on the number line, we're trying to express the function f of x is equal to sin x by x. And you'll see that this function has no problem being calculated on any value from minus infinity to 0. Sine minus 1 by minus 1 will give you a value. Same way, from 0 to infinity, any value is purely permissible by this function. Sine 1 by 1 is an easily calculable mathematical value. It's only at x is equal to 0, right here, is where we get a problem. And just to illustrate this, let's magnify this a little bit. And you'll see that we found the value for x is equal to 0.1 when we got some value. You have a 0, you have a 1. At 0.1, you have a value that's very close. At 0.01, you have a value that's even closer. And at 0.001, you have a value that's even more closer. But at no point have you actually put x is equal to 0, because the moment you put x equal to 0, we just don't have an answer to the problem. So when you're expressing the limit x tends to 0, please do note that x is never actually exactly 0. It is just very, very close to 0. That is the meaning of x tends to something else. Please note this very carefully, because this is something we're going to be using in the further sections as well. Now, moving on, there's some exercise if you'd like to just brush up on what we studied. Just click this link. I'll put a section to it in the video description as well. This basic exercises on limits, and on the next video we'll cover more limits like the ones we just mentioned, sin x by x, and we're going to get into a big chunk known as differentiability. That's all, I guess, and see you in the next video.